velocity is different. At different points, the direction of the velocity is different. At every point of the circle, you can check that the direction of the velocity is changing. Direction of the velocity is changing. So means the velocity is changing. Means the velocity is changing. What is velocity? Velocity is a combination of speed plus direction. So basically in this case your speed is constant, your direction is changing. So you can say your velocity is changing. And what happens when velocity changes? There is an acceleration. Okay. So this acceleration due to change in the direction of the velocity is known as the centripetal acceleration, and the direction of the centripetal acceleration is towards the center. The direction of the centripetal acceleration is always toward the center of the circle. Remember this point. Okay. So r is the radius of the circle. So centripetal acceleration is given by v square divided by r. Okay, v square divided by r. What is v? Here v is the speed. Speed, or you can say the magnitude of the velocity. Speed or magnitude of velocity. So this is centripetal acceleration. Okay, so centripetal acceleration, you know that in a circle, we know that in a circle there is a relation between the linear velocity and angular velocity. There is a relation between the linear velocity and angular velocity. Suppose this body, this particle here at A, there is one particle, and this particle is moving with the constant angular velocity omega. So you can write the relation between the angular linear velocity and angular velocity is equal to v is equal to r omega. Put this value here. So you will get r omega square by r. Okay. So this you will get r square omega square divided by r. Okay, and r will get cancel out. So centripetal acceleration can be given by r omega square. So we have two formulas of centripetal acceleration. Okay, centripetal acceleration. So what is centripetal acceleration? Acceleration due to change in the direction of the velocity. Change in the direction of the velocity. So you can write it is due to change in the direction of velocity you can write at every point the direction of centripetal acceleration is towards center. Okay, so at every point, suppose here at this point also the direction of the acceleration will be towards the center. Okay, will be toward the center. So this is the centripetal acceleration. Another is the tangential acceleration. Tangential acceleration. So for tangential acceleration, this is a circle and this is the center of the circle. So this time there is a particle here and this particle is moving with a variable speed. Speed is changing. Okay, here speed is changing. Okay, speed of the particle is changing. So here, suppose at this point, the speed is suppose v1. V1 is the speed, and this tangent is representing the direction of the velocity. Okay, so basically at this point the velocity is v1. Okay, now at this point, the speed is v2. At this point the speed is suppose v3. Means at every point the speed is changing. Okay, and in a circle direction always changes. Direction always changes, no matter speed is changing or not. Okay, here your speed is constant at every point, but then also you can see the direction of the velocity is changing. Okay, direction of the velocity is changing. Here you can see that at every point the direction is changing as well as the speed is changing. Okay, speed changing and you can say direction also changing. So this tangential acceleration is due to change in the change in the speed of the particle. Okay, this tangential acceleration is due to change in speed of the particle. So basically this tangential acceleration is given by d v by dt. What is v? Speed, and speed is also known as the magnitude of velocity. Okay, so direction of this tangential acceleration will be towards the direction of the velocity. At this point tangential acceleration is in this direction. At this point the tangential acceleration is in this direction. At this point the tangential acceleration is in this direction. Okay, so we know that this acceleration is due to change in speed and direction is same as that of velocity. Direction is same as that of velocity. Okay, here your velocity is in this direction, so tangential acceleration is in this direction. Here your velocity is in this direction, your tangential acceleration is in this direction. Okay, so you should know speed, you should know the velocity. Velocity is speed with direction. Okay, in speed there are two things, one is speed, another is direction. Okay, so at this point this is the direction of the velocity and speed is v1. Okay, at this point this is the direction of the velocity and speed is v2. Okay, so tangential acceleration is given by dv by dt, and what is v? Modulus of v is representing the magnitude of the velocity or speed. Okay. So now suppose the body is moving with a constant speed. If the body is moving with constant speed, then this tangential acceleration will equal to 0. Okay. So if a body is moving with constant speed, on a circular path, then tangential acceleration is equal to 0, but your centripetal acceleration will not equal to 0. Because why centripetal acceleration is not equal to 0? Because centripetal acceleration is due to the change in the direction, and in a circle there is always change in the direction. Okay. Okay. Shafruddin, note down.
Then, sir. Then, sir.
Now the net acceleration. First is centripetal, another is tangential. So if at a point you want to calculate the acceleration, then we will add this acceleration vectorically, then we will get the total acceleration. Okay. So third is the total acceleration. Third is total acceleration. Or you can write the net acceleration. Net acceleration. So I will represent it with AN, net acceleration. Okay, so net acceleration means this is a circle. Okay, and in this case, suppose here the position of the particle is here at this point A. Okay, and at this point, suppose the tangential acceleration of the particle is this. Tangential acceleration at this point, I have told you tangential acceleration will be in the direction of the tangential velocity. So tangential velocity will be will be the tangent at this point, because I want to calculate the total acceleration at this point A. Okay, I want to calculate the total acceleration at this point A. So there will be two types of acceleration. There will be two types of acceleration. If what is happening, if speed is changing, if speed of the particle is changing, so due to the change in the speed of the particle, there will be a tangential acceleration. Okay, and direction is changing. So due to the change in the direction, Due to change in the direction, there will be the centripetal acceleration in this direction. Centripetal acceleration will always be toward the center of the circle. Okay, so basically this is tangent, this is tangent, and this is normal. This is tangent and this is normal. So the angle between the tangential acceleration and the centripetal acceleration is 90 degree. Okay, so for calculating the total acceleration, for calculating the total acceleration, you will add both the acceleration vectorically, because acceleration is a vector quantity. So in this direction, suppose you will get your net acceleration. Okay, in this direction, suppose you will get your net acceleration. Okay, so now if remember one point, if two vectors, suppose this is the A vector and this is your B vector, two vectors are at 90 degree angle, two vectors are at 90 degree angle, then the resultant of those two vectors, magnitude of resultant of those two vectors is given by magnitude of A vector square plus V vector square, magnitude of V vector square. Okay, what is A? A is magnitude of vector. Shafruddin, are you getting? Do you know vectors? Your voice is not clear. Hello?
So let me just change the Wi-Fi, sir.
Yeah, okay.
Can you hear me now, sir?
Now it's okay. Now it's okay. So Shafruddin, now which chapter started in your school? Do you know?
So in school this week we didn't have physics. We're gonna have next week only. This week no physics for me. That's why.
Okay, 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 no problem. So basically, do you know vectors?
It determines the way it moves, right? Vector is like the quantity, right? It's a vector quantity and scalar quantity.
Yeah, yeah. There are two types of quantities: vector, scalar. You are right. So basically, now we have studied the first vector, displacement. So displacement is a vector quantity, and I have told you that vector have the magnitude. Okay, vector have the magnitude. Magnitude means the numerical value. Vector have the direction. Okay, and vector follows the laws of vectors also. For example, I'm just explaining. For example, suppose this is east direction, okay, and this is the east direction now. So someone is applying a force of 5 Newton. Someone is applying a force of 5 Newton in east direction. So basically 5 Newton, what is 5 Newton? 5 Newton is the numerical value of the force. Okay. 5 Newton is the numerical value of the force. And east is the direction. East is the direction. Okay. So you will write force vector as 5 Newton along east. What is 5 Newton? This is known as the magnitude. Okay, this is magnitude or the numerical value. What is east? Direction. What is east? Direction. If I am saying a force of 4 Newton is acting in this direction, north direction. Suppose this is your north direction. Okay. This is your force. Suppose this is your F2 force. At this point, one force is 5 Newton in east direction, another force is of 4 Newton in north direction. Okay. So F2 is 4 Newton. So for F2, what you will write? 4 Newton. F2 is 4 Newton along north direction. Okay. Four Newton along north. Actually, there is a whole chapter vector. There we have completed the motion in a straight line, na? And after that there is a whole chapter vector. So there we study what are the vectors, what are the vector laws. Okay. And suppose this is a point, this is a force of suppose 5 Newton in this direction, and this is a force of 10 Newton in this direction. So basically force is a vector quantity, and at a point both the forces are acting an angle between the vectors 90 degree. Angle between the vectors 90 degree. So at this point the total force is given by somewhat in this direction. Okay, this will be the total force. Okay, and how you will calculate the magnitude of the total force? If two vectors are at 90 degree, square of magnitude of one force plus square of magnitude of another force. So basically at this point, one acceleration is in this direction and one acceleration is in this direction. Both the acceleration are perpendicular. So how you will calculate the net acceleration? Under root of magnitude of centripetal acceleration square plus magnitude of tangential acceleration square. Okay. And if you want to suppose this angle is alpha. This angle is alpha, so you can find the tan alpha also. So tan alpha is given by, okay, so I am just explaining. Basically tan alpha we can write centripetal acceleration divided by the tangential acceleration. This we can write. So see from where I have written this. Okay, so basically I will use this diagram. So this is a point. In this direction there is a tangential acceleration, and in this direction there is a centripetal acceleration. Okay, so this angle alpha, this angle is alpha. Okay, so what you will do, you will just complete this parallelogram. Okay, you will just complete this parallelogram. So this arrow, the length of the arrow is the magnitude of the acceleration, tangential acceleration. So this length will be equal to this length. So means this is also 80. This is also 80. Okay, and length of this is also 80. Okay, this is 80. This is AC. Length of this arrow is AC, and this length is also AC, because this is a parallelogram. Parallel side have equal length. Okay, so now from this triangle you can find the value of tan alpha from this triangle. Suppose this is triangle OAB. So triangle OAB, tan alpha is given by perpendicular divided by base. So AC will be your perpendicular. Okay, AC will be your perpendicular, and your base will be this 80. So basically all these things we study in the vector. Okay, parallelogram law there. Okay, okay, so basically there are three types of acceleration we have studied. First is centripetal acceleration. This is due to change in direction of velocity. Okay, in a circle. Another is tangential acceleration due to change in magnitude of velocity. Okay, and another is the net acceleration. This is due to change in magnitude as well as direction. Of velocity. And this centripetal acceleration is given by v square by r, and this can also be written as r omega square. Okay, what is v? V is speed. What is r? R is the radius of the circle. What is omega? Angular. Okay, omega is angular speed. Okay, and tangential acceleration is given by dv by dt. Tangential acceleration is dv by dt. What is v? V is also speed. Okay, v is also speed. Net acceleration at any point is given by this square under root square of centripetal acceleration plus tangential acceleration. Okay, okay, note down this. we should know the basics of the vectors. Okay, so in the next class we will discuss the basics of the vectors, because I think you do not know the basics of the vectors. That is why uh, you are getting some problem in understanding this concept. Am I right, Shafruddin?
Uh, I think the picture is done.
Hmm. Okay, take the screenshot.
Yeah, done.
Done.
Yeah. So is my voice still lagging or?
Actually, your voice, na, your voice is just cracking,
Oh, okay.
cracking. Hmm. There is some interruption in your voice.
Yeah, yeah. That's, I'm done,
Okay,
sir.
no problem, no problem. You can take the screenshot.
So I took the picture already.
Hmm.
So I took the picture already, sir.
You took the screenshot. Okay. Done.
Done, sir.
Okay.
Done, sir.
Okay. Now we will see some simple numericals. Some simple numericals. Okay. If speed is changing with time, speed is given this. This is your speed. Okay. And radius of the circle is 9 meters. So our body is moving on a circle whose speed is given 2t and radius of the circle is 9 meters. We have to find centripetal acceleration, tangential acceleration, and net acceleration at t is equal to 3 seconds. T is equal to 3 seconds. So basically our body is moving on a circle. Okay, our body is moving on a circle. So suppose this is the position of the body at t is equal to 3 seconds. Okay, so at this point there will be the acceleration. Okay, there will be the acceleration. There can be two types of acceleration. There can be two types of acceleration: tangential as well as the centripetal acceleration. So tangential acceleration, I have told you, will be in this direction. Centripetal acceleration, I have told you, will be towards the center. And there will be one net acceleration here. There will be one net acceleration. This is your net acceleration. Okay. So speed is given as 2t. We have to find the centripetal acceleration. What is centripetal acceleration? V square by r. Okay, so what is V? 2t square by r is 9, and they are asking at t is equal to 3 seconds. So put t is equal to 3. So this will become 2 into 3 square by 9. This will become 3 to the 6, 36 by 9. This will become 4 meter per second square. Tangential acceleration is given by dv by dt. Okay. V, what is V here? I am not writing mod V. V is the speed. So dv by dt at t is equal to 3 they are asking. So you will do the differentiation of this V. So d by dt, instead of this V you will write 2t. So your answer will be 2 meter per second square. Total net acceleration, I have told you how to calculate the net acceleration. Centripetal acceleration square plus tangential acceleration square. So this will be equal to 4 square plus 2 square. This will become root 20 meter per second square. Okay. If this angle you want to find this alpha, I have told you how to calculate this alpha. Tan alpha is equal to centripetal acceleration divided by the tangential acceleration. What is centripetal acceleration? 4. Tangential acceleration is 2. So your tan alpha is equal to 2. So alpha is equal to tan inverse 2. Solving question is not very difficult, but to understand the concept, what is the centripetal acceleration, what is the direction, this this is little bit difficult. Okay, solving the numerical in circular motion is not that difficult, because if you know the formula of centripetal acceleration, if you know the formula of tangential acceleration, then you can find easily. Okay, but to define the direction, all these things are important. Okay, so
Yeah, okay.
one more question I am taking. Suppose the angular velocity omega is given as 2t and radius of the circle is 2 meter. Okay, we have to find the centripetal acceleration, we have to find the tangential acceleration, we have to find the net acceleration at t is equal to 3 seconds we have to find. Okay, so this is again very simple. We know that in a circle we have v is equal to r omega. Okay, in a circle v is equal to r omega. So we will find first the v. What is r? 2. What is omega? 2t. So this will become 4t. So your velocity is 4t. Now this question becomes like this. Accordingly, you can find the centripetal acceleration. V square by r. V square means 4t square by r. Okay. So put the value of t. At t is equal to 3 seconds we have to find. So this is 3, and the square, what is the radius? Radius is 2. Okay. So you can find tangential acceleration.
144 by 2.
Yeah. No, you can do that, I know. You can find the tangential acceleration dv by dt. So differentiate the velocity given. This is 2t na. This is not 2t, this is 4t. This will become 4t because we will put the value of the velocity 4t. So what will be your tangential acceleration? 4 meter per second square. Okay, this will become 144 by 2. So this will become 72.
Yes.
Okay, 72 meter per second square. Okay, so net acceleration, how you will find the net acceleration? Root of centripetal acceleration square plus tangential acceleration square. So this will become 72 square plus 4 square. Okay, so this will be your answer. If you want to find the alpha, tan alpha, so you will write AC by 80. What is your AC? 72. What is your 80? 4. This will become 18. No, this is 2. This is 36. This will become 18. So your, what is your alpha? Your alpha is equal to tan inverse 18. If you want to show this on the diagram, then you can easily show this on the diagram also. This is the circle. Okay, suppose this is the point and this is the center of the circle. This is the radius, and in this direction there will be the centripetal acceleration, and in this direction there will be the tangential acceleration. So net acceleration will be something like this. Okay, and this will be your alpha. What is alpha? Alpha is the angle between the net acceleration and the tangential acceleration. You can find the angle between the net acceleration and the centripetal acceleration by 90 minus alpha. Okay, note down. Done. Okay. So there is one more acceleration in circular motion. There is one more acceleration in circular motion that is known as the angular acceleration. Number 4 is known as the angular acceleration, and this angular acceleration is represented by alpha. So we know the linear acceleration. Linear acceleration means the acceleration we studied. Linear acceleration. This is your linear acceleration. What is linear acceleration? Change in linear velocity divided by delta t. So your angular acceleration, change in angular velocity divided by change in time. So this angular acceleration can be of two types, or we can measure the angular acceleration in two ways. Instantaneous angular acceleration means alpha instantaneous. This will become d omega y dt. I have told you, for instantaneous things delta becomes d. So you, for very small interval of time, delta t tending to 0 means for very small interval of time or at any instant of time. Alpha average you can find by delta omega by delta t. Okay. So we have in linear motion and angular motion or circular motion. Circular motion. In linear motion, we have the linear displacement. In angular motion or circular motion, we have the angular displacement. In linear motion, we have the linear velocity v. In angular motion, we have the angular velocity omega. This linear velocity is given by ds by dt, and this angular velocity is given by d omega by dt. Okay. Linear acceleration is given by dv by dt, change in linear velocity divided by time, change in time, or dv by dt. And angular acceleration is given by d, oh, actually this is d theta by dt. Okay. Linear velocity is ds by dt and angular velocity d theta by dt. Angular acceleration is d omega by dt. Okay. Now we can take one question. Very simple question. Your omega or your angular velocity is changing with time as t square plus 1. Okay, suppose a body is moving in a circular path and angular velocity is changing with time. We have to calculate alpha. Alpha means angular acceleration. Okay, alpha number 1 for 0 to 2 seconds. Second, at 2 seconds. Simple. For 0 to 2 second, you want to calculate alpha, means you want to calculate alpha average. Okay, you want to calculate alpha average. What is alpha average? Delta omega by delta t. Delta omega by delta t. What is delta omega? Omega 2 minus omega 1, or you can write omega final minus omega. Here you can write T2 minus T1. Omega 2. Omega 2 means T's value of this omega at T is equal to 2 seconds. This is your T2. This is your T1. Okay. Omega 2 means this is 2 square plus 1. This will become 5 radian per second. Omega 1 means 0 square plus 1 means 1 radian per second. So now put the value. 5 minus 1, this is 2 minus 0. This will become 4 by 2. This will become 2 meter per second square. Okay, this is your first answer. Second answer, they are asking the angular velocity at 2 is equal to, not the angular velocity, angular acceleration at 2 seconds. At 2 seconds. So Shafruddin, tell me here, what type of angular acceleration we will calculate? What type of angular acceleration we will calculate for the second case?
ds by dt.
Yeah, not ds by dt, d omega by dt. Okay. Instantaneous angular acceleration we will calculate, that is d omega by dt, and at t is equal to 2 seconds we have to find. So now differentiate this d by dt. Differentiate this t, this is t square plus 1. So the differentiation of this will become 2t, and you will put the value of time here, 2 into 2. This will become 4 radian per second square. Okay, here this will not be the meter per second square. This will be the radian per second square, because this is the angular acceleration. Okay, radian per second square. Okay, there is one relation. There is one relation between the tangential acceleration, or you can say the linear acceleration, and the angular acceleration. There is one relation. See how we can derive that relation. Okay, your angular speed, linear speed is equal to radius into angular speed. Okay. Okay, if you divide this with time, okay, if you divide this with time, and here you are dividing with time, so this is, okay, do this in this way. This is your v is equal to r omega we have. Okay, so we will differentiate this equation with respect to time, so it will become dv by dt, and r is constant, so this will become d omega by dt. Okay, what I have told you, dv by dt, dv by dt is your linear acceleration. Okay, linear acceleration. dv by dt is the change in speed. Okay, what is v? V is the speed. V is speed. So basically this is change in speed with time. And what is the acceleration due to change in speed? Tangential acceleration. Okay, so this will become tangential acceleration. This will become r. What is d omega y dt? Alpha. So this is your tangential acceleration. This is your angular acceleration. What is this? Radius of circle or circular path. Okay, note down. Is this completed, Shafruddin, this part?
Sorry.
Okay, so take the screenshot from here.
Done, sir.
Take the screenshot.
Done, sir.
Take.
Done, sir. Done, sir.
Okay.
That's it. That's it. That's it. That's it.
Okay. So basically, today we have discussed what are the types of acceleration in circular motion. So basically, we have studied 4 types of acceleration. Number 1 is the centripetal acceleration. Centripetal acceleration is due to the change in the speed in circular motion, not the change in speed, change in the direction. Okay, change in the direction of the body. When you are moving on a circular path, at every point your direction is changing, and due to change in that direction there will be the centripetal acceleration, and direction of centripetal acceleration will be towards the center always at every point on the circle. Second is the second acceleration we have studied is the tangential acceleration. So tangential acceleration, at any point the direction is tangent at that point. Draw tangent at that point. Okay, and this acceleration is due to the change in the speed in the circular motion. Okay, and third is the net acceleration. Net acceleration means the vector summation of the tangential acceleration and the centripetal acceleration. Tangential acceleration and centripetal acceleration both are at 90-degree angle. Okay, and the last fourth is the angular acceleration. Angular acceleration is change in angular velocity divided by change in time. So angular acceleration we can calculate in 2 ways: instantaneous angular acceleration or average angular acceleration. Instantaneous angular acceleration is given by delta omega by delta t, and average angular acceleration is given by delta omega by delta t. Instantaneous angular acceleration is given by d omega by dt. Instantaneous things, for instantaneous velocity, instantaneous acceleration, we will use d. Like instantaneous acceleration is dv by dt. Instantaneous angular acceleration is d omega by dt. Okay, Shafruddin. So, have you understood the acceleration part in today's lecture? Means,
Yes, I understand a bit. Just a little bit hard when it comes to the numericals.
okay. So basically, you have little bit problem in solving the numerical. Okay, so do one thing. Do one thing. Try these numerical. Try to solve these numerical by yourself once, and after that, if you are facing any doubt, any problem, then in the next class we will discuss that.
Okay, sir.
Okay. Okay.
Yes, sir.
So basically, for the numerical part, you should know the formula of the centripetal acceleration. Suppose in this we have to find the in this numerical, this is the condition given. This is the condition given, means this is the speed of a particle in a circular path is given, and radius of that circular path is 9 meter. We have to find the centripetal acceleration, tangential acceleration, net acceleration at t is equal to 3 seconds. At t is equal to 3 seconds. So basically, what you have to do for finding the centripetal acceleration, you should know what is the formula of the centripetal acceleration. So I have told you the centripetal acceleration is given by v square divided by r. What is v? V is 2t. So square of this divided by radius. Okay, then you will put the value of t, because they are asking centripetal acceleration at t is equal to 3 seconds. You will get the value. Now after that, they are asking the tangential acceleration. For tangential acceleration, you should know first the formula. I have told you tangential acceleration is the change in speed due to change in speed. So you will write dB by dt. You will write dB by dt. So you will differentiate this equation at t is equal to 3 seconds. You will get your answer. Net acceleration is the vector summation of this acceleration and this acceleration. And we know the direction of the centripetal acceleration is towards center. We know the direction of the tangential acceleration is towards the tangent at that point. Okay, at that point, and both are at 90-degree angle. And we know that in case of vector, when two vectors are 90-degree angle, we calculate the resultant magnitude of resultant in this way. Okay, so here, that is why I have find it out the resultant here in this way. Under root of centripetal acceleration square plus tangential acceleration square. So centripetal acceleration is this, tangential is this. So this will be your answer. If you want to find the angle you can find with the help of tan alpha. So tan alpha is given by AC by AT. I have already calculated this part here. How to find the tan alpha? Okay, this here I have told you. Okay, try the questions by yourself. Okay, then if you have any doubt, then we will discuss in the next class. Okay, Shafruddin?
Yes, sir.
Okay, Shafruddin. So that's all for today.
Thank you, sir. Assalam alaikum.
Okay. Walaikum Assalam.